Now we're gonna create our new project for the synchronous data path design. So basically, this our project is gonna be based on the continuation of the neural model. So we're gonna create a new project, and then we're gonna choose the path here. So we're gonna choose this folder, neural model, the new folder, and then we're gonna write here our project's name is neuron, and then it's empty. Now in this project we're gonna use files from the previous project that we have been working on. So we're gonna include the half adders and full adder and ripple carrier adder. So first of all, if you go to the basic, here we have the full adder and the half adder, and then we're gonna include the ripple carrier adder. So this file here, and then we're gonna select our board, the last one, and our simulation, Questa Intel FPGA, and then finish. We're gonna design a 3x2 unsigned integer multiplier that we have discussed in the previous video, this one, how we're gonna create this one to a Verilog file. So the first thing we need to make sure that it is our file that we have included in our projects. It is on the files. So in this design, I'm gonna use ripple carrier adder, but you can use also full adder if you want to choose so. So let's create a new Verilog file and save this Verilog file as m times q multi so we need to set this as our top file. So if you go to hierarchy, and then we need to create the module. So module need to be the same name, times q multi, and then we need to declare our inputs and output. So we know, based on this design, these two, the multiplicand and multiplier, are input, and output is the product. So we have m q multiplier and the product. So we have multiplicand, multiply, and product, and then we need to end the module. And then we need to declare our inputs. So input. So the first input is the multiplicand, and this it is 3-bit. So and then input q with 2-bit, and then this is q, the multiplier. So from 0 to 1, 2, those are 3-bit, and from 0 and 1, those are 2-bit. And then we need to declare our output. and the output, we found out the output, it is m plus q, so it is 5-bit. So here from 4 to 0, p, the product, and then now what we need to do, we need to starting doing this operation. For example, m and if with q for all of this. So we know we have y and x, those need to be summed in the repro carry adder. So if we go to our code here, what we can do now, we can declare a wire, since this is internal wire, and we know, we found out y it is 3-bit and x is 3-bit, and this is an internal wire, they're not going from outside or inside, so it is 3-bit, so from 2 to 0, x and y. So we can assign y, it is equal to, so we can use something called concatenate. So we need to do the first operation, which it is m1 and it with q0, so this is the first operation, which it is this one here, because this operation here go directly to the product, so this operation here for y, and then we can do the next operation, which is m2 and the last operation, which we don't have here, it is 0, so we need to set this as 0, so it is bit 0, and where the way to write bit 0 is 1 b0, and then we need to close this. So this is our y and x, so we need to do assign x. So the first operation for x, it is this one, so it is m0 with q1 to m2. So let's just write it, copy here. So it is q1 with m0 and then it is q1 with m1 and then it is q1 with m2, the last bit. So now you can see all of these two now are 3 bits, so we need to close here. And the next thing we need to do, we need to sum y and x. So what we can do, we can call our repro carrier adder. So it is n-bit RCA, the way we designed in the last project, and then give it a module name. And if we open, so go to the files and open if we open the repro carrier adder, we can see the repro carrier adder, it is n-bit RCA, and then it is carry in x, y sum and carry out. So we need to declare all of these too. So the first input, it is the carry in, and the carry in from this one, it is, when we go to our design, it is 0. So we need to set carry in at 0 bit. And the next position is y or x. So y plus x. And then the result of this, it is sum. So, and then we know this is 3 bits, so we expect the sum to be of 3 bit. So we need to declare as a wire too. So we can say s sum. So we can add here. So the result will be added on this s, which is 3 bit too. And the last one, we have a carry out. So we need to declare a carry out. So wire carry out. So we can write here carry out. So I need to close this. If we remember this, we have designed this as a ripple carrier with 4 bits with parameters. So we need to change this to 3 bits. The way to do it is to write def param, and then the module name is m1 n. You can set is equal to 3. And then we need to assign our product now. So P for the product is equal to, and then we need to do concatenation again. So we know the first bit here, it is this one. So we need to set it here as a first bit, and it is Q0, M0. And the next, it is the sum, which is 3 bit. So it's sum come from here to input here. And the last bit, it is the carry out. As we did here, the carry out. So we can see here, this one is 1 bit. This one is 3, so it's 4 plus 1, it is 5. So let's save it and try to analyze and synthesize. So we can see that we don't have any warnings or error. So in the next video, we're gonna create a test bench file for this multiplication and simulate it to see if we have the expected result.